Section 8.1.25. The shape of the distribution of the time required to get an oil change at a 12-minute oil change facility is unknown. However, records indicate that the mean time is 13.1 minutes and the standard deviation is 6.0 minutes. We want to complete parts A through C below. First part is to compute probabilities regarding the sample mean using a normal model. What size sample would be required? Okay, now according to the central limit theorem, the sampling distribution of the sample mean becomes approximately normal as the sample size n increases. So regardless of the shape of the population, for n being greater than 30, the sample can be considered large. So the sample size should be greater than 30. Okay, next it says, what is the probability that a random sample of n is equal to 35 oil changes results in a sample mean time less than 12 minutes? Okay, so first thing is we need to determine, okay, what is the mean of the sample mean? Well, the mean of the sample mean is going to be the same as the population mean. So the population mean, which means the sample mean, is going to be 13.1. Okay, and so now what we need to do is find the standard deviation of the sample mean. And the formula for that is the population standard deviation divided by the square root of the sample size. So if we take a look up here, we can see that the population standard deviation is 6. And we want to divide that by the square root of n. And so the n is the sample size. So again, we know that the standard deviation is 6. And then what is the sample size? Well, the sample size is 35. So that's 6 over the square root of 35. And if we go ahead and find that on our calculator, we end up getting 1.014185 as our standard deviation. Okay, so now that we know what that is, now we need to compare this result of less than 12 minutes. And so we need to find the z-score of that. So recall that what we're looking for, okay, is the probability of x being less than 12. So that means we have this bell curve where we have this mean of 13.1 and we want to find it to be less than 12. But in this particular problem, we need to convert it to a z-score. So we know that x is equal to 12, and then we're going to subtract the mean, which is 13.1, and then we're going to divide that by the sample standard deviation, which is 1.014185. So the z-score is negative 1.08. So now what we're doing is now we've converted this to a normal distribution, which means now our mean is 0 and our z-score is at negative 1.08, and we want to find the probability that it's less than that. Okay, so we can either use a table or we can use our calculator. So we can start using our calculator here. So what we want to find is the probability of z being less than negative 1.08 is equal to normal CDF of the lower bound, which is negative 9999. The upper bound is negative 1.08. And we know our mean is 0 and our standard deviation is 1. So let's go ahead and put that into our calculator here. So second distribution, normal CDF, we have negative 9999, comma, upper bound negative 1.08 with a mean of 0 and a standard deviation of 1. And so therefore, we're going to get the following as the area or the probability. So rounding it to 4 decimal places, we get 0.1401 as the probability. And again, if we wanted to do this on StatCrunch, then now we know that the mean is going to be 0 and the standard deviation is going to be 1 since we converted it to a z-score. And we know that we want that value to be less than negative 1.08. And then let's go ahead and compute that. And then we can see that we get the exact same area. And so there's using StatCrunch. So therefore we can say that the probability that a random sample of 35 oil changes results in a sample mean time less than 12 minutes is 0.1401. Okay, so now let's take a look at question part C. It says, now suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. On a typical Saturday, the oil change facility will perform 35 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, at what mean oil change time would there be a 10% chance of being at or below? This will be the goal established by the manager. So for this question, we first need to find a z-score that's associated with the 10%. Okay, so with a 10% chance of being at or below. So what it means is that we're looking for an area of 10%, which is equal to 0.1000. Okay, and so it's saying that it has to be at or below. So that means that we have, okay, a mean of 0. And so what we want to be able to do is we have an area here that is at 0.1000, okay, and we want to first determine what is that z-score. Okay, so in order to find out what that z-score is, we can either use a table and look for a z-score of 0.1000. So can we find that? Okay, so let's take a look at the table and we're looking for 0.1000. So let's see here. Okay, so if we take a look at these two values here, okay, so which one is 0.1000 closest to? Well, we can see it's closer to that probability. So therefore, we can then determine that our z-score at that particular area is going to be the following. So it's going to be negative 1.2 and then 8. So therefore, our z-score is going to be associated with negative 1.28. So we get negative 1.28 as our z-score. Okay, now how would we do this on the TI calculator? Okay, so if we wanted to find this on the TI calculator, we're going to look at Inv Norm, where we have the area, which is going to be 0.1. We know our standard deviation is 0, and our mean is 0, and our standard deviation is 1. So let's go ahead and do that on our calculator. So we're going to go to second distribution. We're going to go to Inv Norm. So we're looking for 0.1 as our area. We know that our mean is 0 and our standard deviation is 1. And so therefore there is our z-score if we do not want to use the table. Okay, and then likewise, if we want to use the calculator, we know our mean is 0. We know that our standard deviation is 1. And so we want to find a value that's less than. So we want to look at that area of 0.1. And so therefore there is our z-score if we want to be able to use StatCrunch. Okay, so those are a few different ways of being able to do that. Okay, now we're not finished yet, because what we're looking for is we want to find out what mean oil change time would there be a 10% chance. So remember that we have a z-score formula, and that z-score formula is equal to x bar minus the population mean over the standard deviation of the sample mean. Okay, so what we need to do is we need to solve for x bar. So in order to solve for x bar, we know that x bar is going to equal the following. It's going to equal the population mean, which is of the sample mean, which is the same thing. And then that's going to be plus the z-score times the standard deviation of the sample mean. So in order to find x bar, what we need to do is, now we know that the mean is what? We know the mean is 13.1. Plus we know that our z-score is negative 1.28. And we want to multiply it by the sample standard deviation of the sample mean, which is 1.014185. And so therefore, if we round it to 2 decimal places, we get 11.8. Now what does that mean? Okay, what that means is that there would be a 10% chance of being at or below 11.8 minutes.